Hello everyone, welcome to our third module of our midterm. So we are now more than halfway of our course for food chemistry. Okay, so this time we are going to discuss about lipids. We already Wait, where am I? Okay, here. Okay, we already discussed about the major nutrients such as the carbohydrates, water, of course, during prelims. And this time we are going to proceed to the next major macronutrient, which are the lipids. Okay, so what are these? Okay, so foods contain, of course, fat and oils. Okay, so if you will take a look at our photos, we have our fatty rich foods. Okay, so what are fats and oils? Fats and oils are different types of lipids. Okay, so these lipids are rather diverse class of organic compounds that include triglycerides, phospholipids, steroids, etc. They are insoluble in water but soluble in organic solvents. Okay, so if you have fat and you mix it with water, it will never mix with water because they are immiscible with each other. Now, fats and oils mainly compose of carbon, hydrogen, and oxygen, but with a very low proportion of oxygen in the molecules. So, our our carbohydrates are also made up of carbon, hydrogen, and oxygen. Okay, but this time the lipid molecules are denser and they are more massive compared with our carbohydrate molecules. So most natural fats and oils are mixed glycerides. Glycerides are esters from propane 1,2,3 triol, and that's why we call it glycerol. Okay, so these are the carboxylic acids that are usually unbranched, having 14 to 18 carbons. So the fats and oils have a more complex structure compared with the carbohydrates. There are three ester groups per glycerol, and the three R groups are usually different. That's why we call them triglycerides because of the three R groups. So let me give you an illustration of the structure of a triglyceride. Okay, so we have here our triglyceride. We have our C double bond OH. Okay, so that would be for the carboxylic acid. Okay, and we have our fatty acid tail, and this is our glycerol, which are made up of three carbon atoms. Okay, so an example of the fatty acid is this. We have our stearic acid. Okay, so much more about that structure. This is food chemistry and not biochemistry. Okay, so we will just not dig into the structures of those. Okay, but it is also important for us to learn. Okay, so how are triglycerides being synthesized? Okay, so this is our three fatty acids, and we have our glycerol. So when we synthesize this will become into fat and water molecules. Okay, and if we are going to break the fat, it will undergo hydrolysis, take away the water, or add the water back. Okay, it will become glycerol and fatty acids. So in the next module, we will learn the metabolism of lipids. So let's just have the preliminary this time. So this is a microscopic view of fat cells. We have the hydrocarbon tail again, the ester bond. Okay, for our carbohydrates, they are connected with the glycosidic bonds, and for this we have our ester bonds. So this is a fat droplet if we are going to take a look at the microscope, and this is a colorful one if you are going to stain um, and take a look at the fat cells under your microscope. Okay, so fats come from animals as well as oils, okay, come from animals and plants actually. Okay, so animal fats are lard and butter. They are rich in heavy chain saturated fatty acids and they are solids at room temperatures. While vegetable oils are liquids that have high content of glycerides composed of light chain and saturated fatty acids. Okay, so um, with this, we can determine which fat is healthy and which oils are healthy or not. Okay. Now, fats and oils develop an unpleasant smell if they are kept for too long. Okay, and we call that as rancidity. When it smells bad already, it has that foul smelling aldehydes and carboxylic acids. So we can say that is already rancid, okay, or it has been spoiled. Okay. When you buy meat at the market and when you smell bad, especially of the pork, okay, and you will say in vernacular, ranso na ang baboy. Okay, ranso, that means rancid. Okay, it had already undergone hydrolytic or oxidative reactions. That is rancidity. Okay, so hydrolytic rancidity, the presence of moisture in oils which hydrolyzes the glyceride molecules into propane, 1,2,3-triol, and 3 carboxylic acids. Okay, that is due to the moisture that is in oils because we already know that fat and oils never mix, okay, and the moisture, the water, okay, will react, and that is called as hydrolytic rancidity. So this reaction is speeded up in the presence of certain microorganisms. Of course, in the market, in the public market, the pork is just there on top of their koan, it is being displayed there, okay, it's not inside the refrigerator, so that's why it is exposed in microorganisms. Okay, so over a period of time, more molecules of carboxylic acids are liberated, which may be volatile and have extremely unpleasant odors and flavors. Next, oxidative rancidity. Oxidative spoilage occurs when fats or oils are exposed to air and undergo oxidation. Okay, because air, of course, has oxygen. Okay, and oxygen will reaction with oxygen is called as oxidation. So it results in the production of flavors such as tallowy, a taste of fatty, according to the Yahoo dictionary. Okay, so you can just search about that. Okay, and the oxidation has a free radical mechanism and is accelerated by trace metals. Okay, so auto-oxidation, we have a segment of our carboxylic acid in fat and oil. Oxidation occurs, the reaction with oxygen in air. So you will create a hydroperoxide for that one. So what is a hydroperoxide? It is a flavorless and odorless substance that easily decomposes to form highly reactive hydroperoxide free radicals. So it will create now the aldehydes, ketones, and carboxylic acids. But auto-oxidation can be controlled but not be eliminated, can be slowed down by antioxidants such as BHA, BHT, provitamin A, and vitamin E. Okay, so we have reactions of fats and oils. We already learned about hydrolysis earlier, and this is a reversible reaction, the synthesis and the hydrolysis. Okay, now fats can be hydrolyzed into carboxylic acids and glycerol in an alkaline medium, and our base for that will be sodium hydroxide. Okay, it can also undergo saponification. Saponification is the process in making soaps, actually. Soaps are from fats and oils. If you will do a research, okay, the bar soap that you are using, the bath soap that you are using, those come from lipids with the reaction of a caustic of caustic soda. Okay, caustic soda is NaOH. That is for hard soap. And for soft soaps, you will use potassium hydroxide or KOH. So this one, when you react this, it will hydrolyze and form, okay, the glycerol, and of course the sodium carboxylate. Okay, and this salt here, this is actually salt, will be the soap that you have, the product. Okay, now hardening of unsaturated fat. Unsaturated fat is a fat in which there is one or more double bonds. Okay, so such fat molecules are monounsaturated if each contains one double bond. So unsaturated fat cannot pack together closely. As a result, unsaturated oils exist as liquid at room temperature. So an example for this is the cooking oil that we have at home. Okay, so this is our saturated fat and this is our unsaturated fat. The difference between the two, if we take a look at the structure for saturated fat, all single bonds, while for unsaturated fat, we have our double bonds. Hydrogenation is another chemical reaction which can convert an oil to a semi-solid fat by adding hydrogen to some of the carboxylic acid. Okay, so as a result, they can pack together and has a higher melting point. So this is an important reaction to produce margarine. Okay, and soft spread margarine are prepared by the catalytic partial hydrogenation of vegetable oil. Is because we want our oil to become solid. Okay, that's why hydrogenation or the adding of hydrogen in order to break the double bonds. Okay, so let's take a look back at our illustration. We have our double bond. We are going to break this double bond, so we have to add hydrogen and it will become like this. Okay, two hydrogens are being added, so the double bond breaks. Okay, so that process is called hydrogenation. Now we can use catalytic hydrogenation by in manufacturing margarine. Okay, so we have unsaturated fat, the solid form of vegetable oil. Okay, so say for example, okay, for this one, we have our catalytic hydrogenation from oil, it becomes margarine. We are breaking the double bond here, the double bonds in this long chain of fatty acid. Okay, so that's why it's all single bonds here already. Okay, so iodine value is used to measure the degree of unsaturation in fats and oils. It is determined by reacting fats or oils with excess iodine. Okay, so if we have our labs, we can observe this, the use of iodine in order to measure the degree of the unsaturation in our fats and oils. Okay, so since we don't have our labs, we are just going to do our virtual labs for that one. And you can actually create soap for our lab activity. You can create soap in your own kitchen at home because you can buy sodium hydroxide in some stores there in Ozamis. Okay, so when it comes to energy source, the comparison between our macromolecules, the carbohydrates, proteins, and lipids, lipids have the highest amount of energy. Okay, so we already discussed in module 2, I guess, was module 2, wherein we computed for the calorific values of food. Okay, and lipids has the highest calorific value compared with carbohydrates and proteins. Okay, so because lipids have the highest amount of energy. Okay, so if we do not use the energy again, where it will go? If we are eating, and do not do work, where will our energy go? It will be stored temporarily as glycerol, and it will be stored permanently as fat. So that's why we get our belly fat for that one. All right. So but these are important. Lipids are important because it is a component of a cell membrane. Okay, the cell membrane is composed of phospho phospholipid bilayer. Okay, so it the cholesterol is also important for the synthesis of steroid hormones. Okay, vitamin D, which regulates the absorption of calcium, is derived actually from cholesterol. Okay, so if we are not having too much sunshine, we cannot get vitamin D. That's why the lipids act. Okay, with the cholesterol that we have in our body, we can have vitamin D. It is a component of a digestive juice, which is the bile. Okay, bile salts are made in the liver with cholesterol as a raw material. Okay, so cholesterol is very important, of course, in the function of our brain also. Okay, the healthy fatty acids, the omega 3, is also good for the heart. Okay, heat insulation. Okay, fats, lipids will enable us to protect our body from the abrupt changes into temperature, especially. Okay, it is very applicable in countries that have winter. Okay, because of winter, we need much more heat from the body, and that's the time that we need the fats. Okay, because it will insulate us from the too much cold. Okay, so protection. Fats serve as caution, okay, from injuries, because um, say for example, there you do not have fat, you are very slender and you do not have fat. Okay, you will easily hurt yourself because there is no caution. Okay, but if you have fat in your body, you can just bounce, you can protect yourselves from physical injury because you have caution and just bounce. Okay, so this is our cell membrane. It is composed of a phospholipid bilayer. Okay, so lipids are there, phosphorus are there. Okay, and it will hinder some bad chemicals to enter our cells. Okay, so credits to the following people for this slideshow that I had taken from the internet. Okay, so for your module will just be giving you, okay, I will share to you a part of your module. Your module gives you a link on what lipids are, so just read through this link. Okay, this is a very good read for you guys, for you to fully understand or understand more about lipids. And for what you're going to answer as your activity in your module, they are all very easy. Everything is taken from the readings, everything is taken from the PowerPoint. So it is objective for this time, but for the next module, it's not objective. Okay, so thank you very much for watching again and for listening. Kindly do your module readings before Sunday, before the deadline, and please do come to our discussion hour. See you again next time. Goodbye.